Okay. So today we're going to start chapter 6. We finished up chapter 5. We're not going to do a chapter 5 test. Like I said, we'll include the chapter 5 test when we do chapter 6. Because chapter 5 is only 2 sections. So chapter 6 is all about triangles. Like I said, chapter 5 is the beginning of geometry, and from here on out we're going to stay in the world of geometry until I decide we want to hit some probability, and even then I think that's it. Okay, so let's start at the very basics. So if I have a triangles, yep, so if I have a triangle like that, and I'm told that this is angle 1, angle 2, and angle 3. If I add up angle 1, angle 2, and angle 3, what do they add up to be? 180. So there's 180 degrees inside of a triangle, right? All three angles, no matter what the triangle looks like, they add up to be 180. Ooh, I need to tell you right here. What does that sign mean? Angle. Does everyone understand that? I understand that right now. This means angle. So angle 1, angle 2 plus angle 3 is 180 degrees, right? So if I have a triangle, let's say we have a triangle, and I'm going to regret, this is one of the reasons why I like my smartboard. That little program I do allows me to create triangles. So you're going to have to just kind of be patient while I teach this, because they're going to look a little bit weird. If I'm told that this is 33 degrees, this is 90 degrees, and that's x, Sam, how would I find x? Okay, good. So Sam's basically saying, well, I know that all three angles add up to be 180, right? So what we can do is we can combine the two angles, and then it's just a simple arithmetic problem. X equals, is that 57? So we know that x is going to be 57 degrees, right? Because there's 180 degrees inside of a triangle, we know that. Okay, we're going to learn a lot of different types of triangles, but there's mainly 3 that we're going to focus on this section. The first is acute. What does acute mean? Yeah, all angles are less, so we have an acute triangle like this. This is an acute triangle, which is all angles less than 90 degrees. So this could be like 50, 50, and 80. Right, that'd be an example of an acute triangle. All angles are less than 90 degrees. What's a right triangle? Yeah, so for example, this would be an example of a right triangle. Is any time a triangle has a right angle. So right triangle with a right angle. What do you guys think the last one is? It's an obtuse triangle. So this triangle is going to look like this. Obtuse triangle. And Andy, what is it? Okay, what does obtuse mean? Triangle that has an angle greater than 90 degrees. So this could be like 140, 20, and 20 or something, right? So there's 3 different types now. I had a professor in college. It was my trigonometry teacher. She was this sweet old lady that taught trigonometry. We started talking about triangles, right? And she was telling us about acute, right, and obtuse triangles. And she was saying, now the way I remember these is anytime somebody hands you like a puppy, right? Puppies are these little tiny things. Oh, cute, right, girls, right? You guys all understand, right? Oh, so cute because it's so small and so cute. That's what an acute triangle is. All angles are small. On top of that, if we have an obtuse one, obtuse is just basically another word for huge, right? So, obtuse is going to have one that's just great big. Okay, any questions on any of that? Are we good? Okay, all right, next thing. It's titled The Extended Angle Theorem. Okay, what that means is this. I'm going to draw it. Is that okay? Instead of writing out a definition, I'm going to draw it. So if I have a triangle that looks like this. Okay? What this thing says is if this angle's angle 1, and this is 2 and 3, angle 1 equals angle 2 plus angle 3. Yes, this is always the exact same. The extended angle of a triangle equals the two angles inside the triangle opposite of it. I don't think so. Did we learn this? 8th grade? Okay. Okay, so angle 1 equals angle 2 plus angle 3 no matter what. Now that can go either way, right? If I had an extended angle here, this angle would equal this angle plus this angle, right? Because they're opposite from it. It's not the angles that are next to it, it's the angles that are opposite of it. So angle 1 equals angle 2 plus angle 3. That is called the exterior angle theorem. So if I have a problem like this, and I'm told this is 145, and I'm told this is 38, and that's x, how would I go about solving for x here, Daxton? Yeah, so basically your formula is 148 equals 38 plus x. So all we're doing is just subtracting 38 from both sides, and we get 107 equals x, which that picture does not look like 107, but I'm going to teach you something right now, why I did this picture just like this. In the world of geometry, and everyone hear me out right now, do not trust the picture. Always trust your math. On the ACT test and other tests, they're going to give you a picture like this. And they'll say solve for x, and you're going to get 107, and you're going to say there's no way in the world that angle right there is 107. Right? Because that's an acute angle. You can definitely tell that angle. Don't trust the picture. In fact, right now, inside your journal, I want a great big star that says, do not trust the picture. Do not, yeah.
Like 150 years from now, people are gonna like see my notebook as like an artifact, and they're gonna be like, "What does this mean?" And they're gonna overthink it. And they're like, what does do not trust the picture?
Are you gonna say like you're a famous guy?
Your book's gonna be an artifact.
Bro, I don't know.
Your book's gonna like deteriorate.
Deteriorate.
Books from old times that are artifacts.
Oh my
I
god.
don't mind.
Oh yeah, it's like our
Because you
Tyson.
look like an ad.
What?
So,
There's
Maybe-
artifacts
Why did this
that
come up?
have-
Maybe Tyson will become famous.
Yeah. There's a lot of famous types.
Mike?
Close enough.
Okay. Any questions on the exterior angle theorem, or can I go on? These are actually pretty basic. I want to get to the little bit. Okay. Now, all these theorems can kind of come into play. What we learned in Chapter 5, what we're learning right now, with what's coming next. So I'm going to do a couple different problems right here, and I would encourage you to write them down inside your journal. If I have a set of parallel lines, So the way I know they're parallel, they'll either say they're parallel or they'll have little arrows on the middle of the line like that. That means they're parallel. And if I have a built-in triangle like that, okay, if I'm told that this is 45 and that's 96, and then if I asked you x, okay, I need some ideas. How would I go about finding x here?
45 plus x equals 180?
Nope, I don't see that.
Plus 96 equals 180, you get that number, and you realize that number.
Okay, so there's a couple different ways we can do this. Look, oftentimes in geometry, they're going to give you problems that look like this. The answer is actually, it's pretty close to here right now. The issue is we see a bunch of numbers and we kind of get confused in the world of geometry, right? Think about what we know. One of the theorems we've already learned is alternate interior angles, right? If we look at this, if we extend this transversal like that, we know two things. We know this entire angle, so that entire angle equals that angle. Right? How do we know that? Alternate interior angles, so that entire angle equals that entire angle.
No way.
So we know that x is going to equal 141 degrees because of that. So, like, look, you could see this and you're thinking to yourself, well, this doesn't make any sense. But look, you could actually do this other ways. Now look, that's just one way to do it. If I have the exact same problem, this is why a lot of people really struggle with geometry, is because there's not just one set ways a lot of times to get to the solution. So if I have this, what's another way I could get to this answer? Would I know what this angle is right here? Well, how do I know this angle right here is 45? Yeah, once again, that's alternate interior angle, so that's a transversal. These lines are parallel. Then we can go 45 plus 96, right, and get 141. Subtract that from 180, we know that's 39. And then by linear angles, we know that this would be 141, right? So there's a couple of different ways you could actually get to the solution there, but we have to be able to, that's why when I said when I started doing this problem, sometimes you got to go back to chapter 5 to be able to get to the solution they want you to get to. I'm not going to spend any more time on that kind of problem. Is everyone okay with that right now? Because I'm just trying to go through some of the problems you're going to see on your homework today, just to kind of give you a brief introduction to solving some of these. Okay, what about if I had this? So if I have a triangle, Allie, what does that mean right there? What kind of triangle is that? A right. Yeah, good. So we know that's 90 degrees, right? A right triangle is 90 degrees. So if I'm told that that angle right there is 5x plus 6, and I'm told this angle right here is 4x plus 30. Let's say I wanted to find, let's label this R, Q, and S. And I needed to find angle R, angle Q, and angle S. How would I do it? Someone give me an idea. Well, first off, what's angle R?
90 to 70.
90.
90. Okay, what do you mean? Daxton?
With, like, have those two on one side equal sign.
Okay, so we know that these two angles have to equal 90. How do I know that, Daxton?
Because there's already an angle that equals 90.
Yeah, because there's 180 degrees and there's already an angle that equals 90, I know that these two angles right here have to add up to be 90 degrees. So I can go 5x plus 6 plus 4x plus 30 equals 90. Could I? Yeah, there's a bunch of different ways you can do
Set it
that.
equal to 0 and then solve for x. Well, not solve for x, but like
I don't.
figure out if one of them's 45.
I wouldn't do that. That could take a long time. Because odds are, I mean, you're talking about 1 in 90 chance that one of them's 45. So, I guess 2 in 90. So, we do this. We get 9x plus 36 equals 90. Is that right? So, 9x equals 54, or x equals 6. Now that we have x equals 6, how can we figure out the measure of those two angles? Yeah, we can plug them back in. So if we plug them in for Q, 5 times 6 plus 6 is 36 degrees, right?
Yes, sir.
4 times 6 plus 30 is 54 degrees. And we're done. Okay? Any questions on that one? I'm going to give you one of those to do on your own. Questions on it real quick? I'm going to give you, this one's going to be a little bit tougher, but I think you guys can still do it. Okay. Everyone's still writing. I like it. Tick, 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 tick. All right, here we go. So if I have a triangle here, I'm going to draw it kind of big here.
Do you want us to draw big as well?
It's up to you. Okay, don't assume that's 90 degrees. We can't make assumptions unless, yeah, okay, a little square. Even though it looks like it could be 90, we don't know, right? So if that angle's x plus 2, that angle's 7x, and this angle right here is 3x plus 2. And let's name this A, B, and C. Tell me what angle A equals, angle B equals, and angle C equals. Let's see if we can get to it. That's 3x plus 2 right here. Well, I don't care whose race is there. Andy, do you like geometry or algebra better? Me too. I like being able to just go geometry. It's yeah, it's kind of funny how it is. A lot of people will be one way or the other. Very rarely are people both where they like them equally. And I mean, I'm decent at both, but I mean, I can tell you right now, if I was given an algebra problem or a geometry problem, a choice, I'd take algebra 100% of the time.
What if it was like the easiest geometry problem?
Well, then it's different, but okay, here we go. Sophia, what do I got to do?
Adding them all together and putting each of them in.
Awesome. I hope everyone did the exact same. You add them all up equal to each other, and then you set them equal to 180. So you get 11x plus 4 equals 180, right? So we solve this, we get 11x equals 176, or x equals what, Sophia? Okay, so we have our x. Angle A. Angle A is what? Angle B? Angle C? Is that really it? Yeah. There you go. Who got them right? Raise your hand. Okay, let me check real quick. I think there's something else I still have to cover. Okay, that's it. Okay, any questions? All right, good. I'll get it up here in just a sec. So, a lot of material.